A raw earthquake record should never teleport from an API into a dashboard. Teleportation is wonderful in science fiction. In data engineering, it usually means nobody can explain what happened. Data Culina uses 7 processing layers, so every handoff has one job, one boundary, and evidence you can inspect. We will follow the same U.S.G.S. earthquake event from its source, through landing, archive, delta, staging, integration, EDW, and consumption. 7 stops can sound excessive, but each one answers a different operational question, and removing one usually makes another layer quietly do 2 jobs. Under the hood, the canonical architecture has 2 responsibility groups, ingestion and transformation. For this walkthrough, we will organize the journey into 3 teaching bands: capture, refine, and serve. Those are navigation labels, not new framework phases. The framework responsibilities remain exactly where the documentation puts them. The journey begins when orchestration hands an approved JSON payload to the shared Culina runtime. The ingestion entry point resolves the source connector, the watermark, and the requested load behavior. Then source to landing acquires the event from the source and writes it to the first framework-controlled persistence point. Approved context already travels with the payload, so the workload never needs to reopen the control plane. Landing keeps the source extract raw or near raw. A JSON response may stay JSON, or it may be stored as Parquet for efficiency, but changing the box does not change the responsibility. No business model transformation happens here, and semi-structured data is not flattened into its final table shape. From landing, an optional archive fork preserves the ingested extract for traceability, recovery, or replay. Archive is a preservation layer, not a transformation layer. It gives the team a clean answer when someone asks, "What exactly did the source send?" That is much better than everyone searching old download folders. Landing to Delta is the first major standardization point. This is where semi-structured payloads are flattened, approved columns are projected, types are standardized, and the data becomes a proper table-ready Parquet structure. The schema created here determines the structure that will be appended into staging. That boundary protects the original extract while making downstream structure predictable. Delta to staging appends that standardized output into the framework's true bronze layer. Staging is the first persistent table-oriented layer used by downstream transformation logic. It keeps the ingestion history needed for later processing and becomes the source for the next incremental boundary. Support teams can inspect what arrived before modeling begins. It is durable bronze, not the final business model. Full load ingestion still appends first, then retains the latest 7 load date copies to control growth. Delta load ingestion appends records as received. The physical table format can vary. Delta tables on Azure, Fabric, and the local engine, or Iceberg on AWS. The logical staging responsibility stays the same. Before staging data enters integration, the framework always deduplicates it. Watermark logic selects only the new staging data that belongs in this run, even though the integration target itself is rebuilt with truncate and load behavior. A useful shorthand is incremental in, rebuildable out. History remains upstream and downstream, not inside the workbench. Integration is the primary transformation workbench. The earthquake rows can be filtered, joined, mapped, deduplicated, aligned to the target model, enriched with system fields, and given a row hash. Business rules become explicit, ordered steps instead of mystery code. Our staging earthquake table becomes integration.earthquake event. Integration is model aligned and useful, but intentionally transient. Integration to EDW moves the modeled result into durable warehouse persistence. Depending on the target design, the writer can append, upsert, merge, or apply SCD to historization. This is where long-term modeled history belongs. The orange earthquake event stops being a temporary work product and becomes a governed warehouse record. After a successful transformation, required unit tests check data integrity, duplicate business keys, and null business keys. If a required test fails, the job fails. A table write by itself is not framework success. For SCD2 targets, effective and expiry dates are included in the uniqueness grain, so valid historical versions are not rejected. Consumption is the optional serving layer. It reshapes trusted EW data into curated, aggregated, or report-optimized datasets for a specific audience. A dashboard gets the view it needs without forcing reporting logic back into the warehouse model. Consumption is the lens. EDW remains the vault. Throughout the run, the payload travels down into the Culina runtime, and structured evidence comes back up. The result artifact can include status, row metrics, watermark details, storage locations, step results, validation outcomes, and diagnostics. Orchestration reads that result, updates the queue, and records official run history or failure evidence. The same logical journey can run through AWS, Azure Synapse, Microsoft Fabric, Azure Databricks, or Culina Engine on a local machine. Storage services, catalogs, identities, and table formats vary. The payload, shared runtime contract, layer responsibilities, and returned evidence stay stable. That creates a traceability spine without pretending every platform is identical. Source data is captured in landing. Archive preserves the original. Delta standardizes the structure. Staging keeps durable bronze history. Integration builds the target model. EDW preserves governed history. Consumption serves the audience. 7 layers are not bureaucracy for its own sake. They make the journey recoverable, testable, and explainable. Explore the framework at dataculina.com.